perfect. Yeah? Okay? So this is the inverse property of logarithm. Any question? Okay? You only need to check whether they have the same base, right? Okay, this is a product rule of logarithm. So log of a product is the sum of two logs. What is the quotient rule? The quotient rule says log to the base A of a quotient m over n give you the log to the base A of m minus log to the base A of n. All right, what is the change of base formula? Log to the base A of m, you can rewrite it, okay, as a quotient of two logs, which is log any base b of m over log to any base b of a. So you can write it as log to the base 10 of m over log to the base 10 of a, or you can write ln, which is the log to the base e of m, over ln, which is a log to the base e of a. Does it make sense? Yeah. Okay. Now let's solve these logarithmic equations. Log to the base a, 5x minus 2 equals to 4. What would you like to do? Well, let's try to think about the definition of log. Okay, you want x, right? So you need to take away this log. So what is the equivalent exponential expression? The base is what? 3. The exponent is what? 4. So using the definition, it says it's 5x minus 2 is 3 to the power 4. Is that right? So 5x minus 2 is 81. So 5x. Are you recording this? So it's going to be on. Okay. So 5x is what? 83. So what is x? X is 83 over 5. Okay. Now you need to check, right? We want to check two things. First, you want to check the domain. Yeah? Is 83 over 5 making this positive? So 5 times x. X is 83 over 5 minus 2. You ask yourself, is that positive? So let's see. Oh, yes or no? 83 minus 2. Is that positive? Yes. The second thing is, you try to check whether it will make the equation equal, right? So plug it in. Log to the base 3, 5 times 83 over 5 minus 2. Will that make it equals to 4? Well, 5 and 5 are common factors. So inside is 83 minus 2. What is 83 minus 2? 81. So it says log to the base 3 of 81. Is that equals to 4? Yes or no? Yes. So you check. It is making the argument greater than 0, and it makes the equation true. So this is your answer. So usually we write in the solution set. Okay? Yeah, can you move it? Okay. Second question. This is a log equation, but you have how many logs? How many logs? 2 logs. Okay? Would you like to try it? I will let you try it for 1 minute, and you tell me what do you do. When you have 2 logs, what would you do? It's a sum. Put them together as a single log. Wonderful, wonderful. So how do you put them together? What is the property you use? Product rule. Okay? You can write this as a single log. Okay? Because they have the same base. So single log, and then what? It becomes 3x minus 1 times x, right? Because the log of a product is sum of 2 logs. That equals to 2. Okay? What is the base here? The base is 2. Okay? So now we know we can write this. So the log is gone, right? Because you really need to solve for x. So how do you take that log away? You use the definition. You use the definition. Okay? 3x minus 1 times x, the whole thing is 2 to the power 2. Does it make sense? This is a definition of log, right? Or you say write log as an exponential form. Okay? Now you're done. This is what? 3x squared minus x. This is 4. So you can make it minus 4 here. So now do you have? Can I factor it? This is a quadratic equation, right? Can I factor? Yes. Okay, I'll let you factor it.
What was the rule that we used?
Okay, so let's finish. This is 1 and 3, and then 1 and 4. Okay, you need to have negative 1, so you get negative 4 here, right? 1 times negative 4 is negative 4. So you get x plus 1 times 3x minus 4 equals to 0. So x equal to negative 1 or x equal to what? 4 over 3. Do we need to check? Yes. Yes. We want to check. Okay, so let's check. First of all, is negative 1 okay? No. Yes or no? No. No, because what? It cannot be negative for the log. The domain for log has to be what? Positive. So you check. Okay? First you check domain. X equal to negative 1 cannot, right? Because you check here, it make it negative. Sorry. But how about negative 1 for this one? 3x minus 1. But it's already making 1 not possible. You don't need to check the next. Do you understand? Okay. So that is for x equal to negative 1. How about for x equal to 4 over 3? When x equal to 4 over 3, 3 times 4 over 3 is 4. 4 minus 1 is 2. So it's okay, right? So for 4 over 3, it's okay. Am I correct? I don't have space, so I try to have you using your mental math. All right. The second check. The second check is see whether we'll make the equation true. So now you only have 4 over 3 to check. So log to the base 2, 3 times 4 over 3 minus 1 plus log to the base 2, 4 over 3. And I ask, is that equals to 2? Right? Well, 3 and 3, they are common factors. So you have log to the base 2 of 3 plus log to the base 2, 4 over 3. Well, that equals to 2, right? Is that right? Will that be? Yes or no? This is a sum of 2 logs, so you can become a single log, right? Yes? It will become single log 3 times 4 over 3. What is 3 times 4 over 3? It's 4, right? Yes? Yes. You will have log to the base 2, and then 3 times 4 over 3. And you ask yourself what that equals to 2, right? That is log to the base 2 of 4. What that equal to 2? Yes or no? Yes. So your check is done. So what is your answer? So your answer should be 4 over 3. Okay? Box your answer. Some of you ask me what are the properties that I use for the part A question. Here, this is just using definition. Nothing but definition, right? The definition of log. And then you just solve. This is just a linear equation. Nothing that you use, just simplify it. Yes?
For the check for the second part,
Uh-huh. Well, it's not in the domain. Why do you need to check it? Here? What is 4 minus 1? What? Here. 3 times 4 over 3 is 4, right? And then 4 minus 1 is what? 3. Here. How does it equal to 2? Because this is what? Log to the base 2 of 3 plus log to the base 2 of 4 over 3. This is a sum of two logs. You can make it a single log of the product, right? So single log of the product of 3 and 4 over 3. 3 times over 3 is what? 3 over 1 times 4 over 3 is 4. So log to the base 2 of 4. Is that equal to 2? Yes. How do you know that? How can you not to know that? Log to the base 2 of 4. What is that? That is the power. 2 to what power equals to 4? 2. Log to the base 2 of 8. What is that? 3. Log to the base of 2 of 32. What is that? 2 to what power give you 5? Okay? It's okay. Log is your new friend. So we need to spend some time playing with it. Okay? All right, let's move on. For this question, I think you can handle it without me. Why I say that? Okay, first of all, do you see on the right side how many terms?
1.
Right-hand side has how many? Oh, I'm so sorry. That's part C. How many terms on the right-hand side? 2 terms. One is number, one is log. Okay? And the left side has log, right? Let's move all the logs on one side. Do you know what I'm saying? Okay, so let's move all the logs on one side. Okay? Now this is easy, just like the previous problem, right? So all the logs on one side, you can put them together. So it will become a what? A log to the base 2 of the product. Does it make sense? Mm-hmm. Equals to 2. Okay? What's next? Using the definition, right? This is a what? Product rule, right? Now, using the definition of log, you will say x plus 2, x plus 5 equals to what? 2 to the power 2. So x squared plus 7x plus 10 equals to what? 4. Right? Now this becomes easier. X squared plus 7x plus 6 equal to 0. And we can factor it. It will become x plus 1 times x plus 6 equal to 0. So x equal to negative 1 or x equal to negative 6. Now you have 2 possible answers. We need to check, right? So let's check. First, we check domain. You have 2 answers. One is x equal to negative 1. Is negative 1 okay? So let's check. Negative 1 plus 1 plus 2, is that positive? Yes. X plus 5, is that positive? Yes. So that is okay. Okay? For x equals to negative 6. Negative 6 plus 2, is that positive? No. Sorry. Negative 6 cannot be one of the possible solutions. Does it make sense? This is just checking whether they are in the domain of this equation. Okay? Only x equal to -1 is positive. It's possible. -6 will make this negative. Sorry, you're out, right? Then you don't even need to consider it. Okay? All right. Now, the second check is you want to check whether it will make the equation equal. So you have to plug in -1. So you have log to the base 2, -1 plus 2. You ask yourself, put the question mark, remember, question mark 2 minus log to the base 2. -6, I'm so sorry, -1 plus 5, yeah? Okay? What do you see? Log to the base 2 of 1 is what? Log to the base 2 of 1. What is log to the base 2 of 1? It's 0, right? This is 0. How about here? Minus log to the base 2 of 4. What is log to the base 2 of 4? What is this? Alberto? 2. So this is 2 minus 2. Are they equal? Yes. So now you finish your checking, right? The whole thing here is checking. Now you're done. You know x equal to -6 cannot be your answer. And you checked when x equal to -1, you will make the equation true. So now you have your answer, just -1. Does it make sense now? Part D. I'm not going to do this. I will leave this as your homework. Let's do the next. Solving exponential equation. Okay? Again, I would like to go over the second one. That's true, huh? Okay. Can I have you do the part A yourself? Okay. Let you have 2 minutes. Do the part A. I think many of you have already done. Yeah. Some of you already already got this done. 2 minutes, because this is not so hard. Part A is easier than part B. Okay? Give you 2 minutes. One more time. One more time. This problem, let's quickly review. First, you take the log on both sides, right? And then you use the power rule, bring down the exponent x minus 2. Make sure the exponent is all together. So you know that you need to distribute. And after you distribute, there are only 2 terms. Okay? There are 2 terms. Now, this is a variable term with x. You keep on one side, and all the non-x term move to the other side. And you just need to isolate x by dividing both sides by ln7. This is your exact solution. And then the approximation solution will be, what is that? 2.8270 approximately. Is that right?
Yes.
We have the order of operations that you need to do exponent first and then you do multiplication, right? Can I have 4 times 3 first? May I? No. If someone got this, okay? Sorry, it's wrong. This is wrong. Why not? Because exponent has higher priority than multiplication. The exponent has higher priority than the multiplication. Okay? So you should not. You can not multiply 4 and 3. Okay? Because exponent has higher priority than multiplication. Okay, so what should we do then? Well, this is an exponential equation, so you want to what? Take log on both sides, okay? And make sure the power rule will bring down the exponent. Let's do it. 4 times 3 to the power x minus 1 equal to 5 to the power x. When you take log, now I'm taking log with the base 10. Remember, you are taking this on both sides. So on the left side is a product, so you need to use the product rule. Okay? Using the product rule, it will become what? Log to the base 10 of 4 plus, thank you, log to the base 10, 3 to the power x minus 1. Okay? Can you tell me what is the property we use, or what is the rule we use? Product rule. Thank you. Now, to bring the exponent down, what is the rule we call? Thank you. Yes, it's called power rule. Okay? You can bring the exponent down. So you get log 4 plus parentheses x minus 1 log 3 equals x times log 5. So far, so good? Okay. Where is the x term? We need to collect all the x terms, right? Well, here you have x minus 1 times log 3. So you need to distribute. You need to distribute. You need to distribute. Okay? Make sure you take notes. So what do you have? You have log 4 plus x times log 3 minus log 3 equals x times log 5, right? Okay? Collecting the like terms, Maybe you would like to put this on the right-hand side. You may. You get log 4 minus log 3 equals x of log 5 minus x times log 3. Okay? Now you can factor x on the right-hand side, right? So log 4 minus log 3 equals x times log 5 minus log 3. Does it make sense now? So how do you find the x? You divide both sides by log 5 minus log 3. Thank you. You divide both sides by log 5 minus log 3. Okay? So x equals log 4 minus log 3 over log 5 minus log 3. Okay? Wonderful. Can I simplify? Anybody try to divide this out? Can you do that? No, no way. Because what? This is subtraction. It's not multiplication, right? Zaya? So that is the final solution, which is the exact solution. So the exact solution, this is your exact solution. Okay? That's your exact solution. You can write there. What is your approximation of the solution? Then you use your calculator. When you use your calculator, you have to be very, very careful. When you're punching those keys, you have to put parentheses surrounding the numerator and putting parentheses surrounding the denominator, because you meant this as a whole. If you don't do that, the whole idea will be different, right? Do you understand? Anybody can tell me why you put the parentheses surrounding the numerator? Say that I didn't do it. I just keep punching log 4 minus log 3 divide log 5 da 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 da. Then the calculator will consider, okay, log 4 minus log 3 divide, you only have log 3 divided by log 5. It's totally messed up. Does it make sense? You have to put what? Parentheses surrounding the denominator and numerator. So when you do the approximation, make sure, I will write here just to make sure that you understand when you do the calculator work. You must put the parentheses, okay? And that is approximately how large? What is that approximation?
0.563.
Is approximately 0.563. Okay, make sure you put the parentheses when you punch in those keys. All right. Great. Is it okay now? Okay, good. Part D is easier than part C. I will leave that to you. Let's do number 4. Solving absolute value equations. You have to review what do you mean by absolute value. Okay? What do you mean by absolute value equals to 3? What do you mean by absolute value equals to 3? When absolute value of x equal to 3 means what? X equals to 3 or negative 3. How about when absolute value of x equal to negative 3? Absolute value would always greater than or equal to 0. Could that be negative? No. So if someone asks you to solve such an equation, you say what? No solution. Okay. By having that, you know it is very, very important when you solve any absolute value equations, you want to isolate that absolute value part. Okay? And you will consider whatever inside as the whole stuff. Okay, one more time. Let's come back to this. Some stuff. Well, when I say some stuff, it's an expression. Consider the absolute value of that stuff equal to 3. Then you say the stuff equal to 3 or the stuff equal to negative 3. Does it make sense? Okay, now let's look at this example. It will be very, very clear. I want to solve absolute value of 3 minus 2x equals to 5. So I put this circle surrounding 3 minus 2x just to remind you. Consider that as a whole stuff. A whole stuff. Zayat, did you get what I say? Okay. Treat the whole thing inside the absolute value as a whole. And I am trying to find absolute value of that equals to 5. Okay? So that means what? The whole stuff within the absolute value should be what? 5 or negative 5. So it's this. So the whole thing, what is that whole thing right now? 3 minus 2x. Should be 5 or negative 5. I will pause here because I need to make sure you know what I meant before I move on. Would you please share what you understood?
Okay, so
Come here.
So you told us earlier that between the absolute value has to be when the whole stuff has to be negative equal to positive or negative. So here,
Do you get that? When absolute value of x equal to 3, that is equal
when there's absolute
3.
value, the outcome is positive or negative. So when we came here, this whole stuff has to be positive or negative. So here it says equals to 5, it has to be positive or equals to negative.
Is that okay? Great job. Extra point. And the rest, I don't need to do for you. Because you know how to solve from here, right? Once you get that, then you can solve it without any question. Right? So 2x equals to 2. You subtract 3 on both sides. Or negative 2x equal to negative 5, negative 8. and then x equal to -1 or x equal to 4. So you had two possible solutions. One is -1 and one is 4. Yeah? Is that okay? Yeah. You would like to answer in solution set, okay? Putting all the possible solution in a set notation. Okay? So right now you have two solutions. One solution is -1. The other solution is 4. So you will graph on the number line, they're just 2 points, right? It's just 2 points. Right? There's no any shading, just 2 points. How do you shade them? No way to shade, right? Just 2 dots, right? One dot is -1. The other dot is 4, right? Does it make sense? The set notation is this. It's a set, has 2 elements, has 2 numbers. There's no interval notation because just 2 points. Does it make sense? Okay. All right. Next problem. Okay. Ready now? No. Okay, next, if we have part B that involve with not just the absolute value part, but other operations, okay? So what do we see? 5 minus 2 times x plus 1 equals to 1. Do you see? You have 5 minus 2 times the absolute value factor. Can I have 5 minus 2 first? No, because what? The 2 here means 2 times, right? The 2 times. Times multiplication has higher priority. So you cannot separate the 2 with the absolute value. No way, okay? This has to be together. So I would like to isolate the absolute value part. So right now I can only subtract 5 on both sides. Does it make sense? Okay? So I subtract 5 on both sides. So I get this. -2 times this. Now, it's multiplication, so I can divide both sides by -2. So you get absolute value of 3x plus 1 equals to 2. Does it make sense? So what is the stuff right now? It's this, right? So whatever stuff inside the absolute value should be what? 2 or -2. Now the rest is easy for you, right? Once you get that, you say, well, 3x equals to 1, so x is 1/3, or 3x equals to -3, x equals to -1. Does it make sense? Of course, you want to check. Yeah. Yeah. You check. Of course, there will be. Okay. Now you answer it. There are only 2 points, so you just answer solution set with a set of 2 elements. And then you graph on the number line. There's only 2 dots. Okay, only 2 dots. There's no interval notation. Does it make sense now? Zayang? Can I what? Okay. Does it help? Okay. Now, this is the absolute value. I want you to look at the part D. D. Part D is solving 2 absolute values which are equal. So I need you to look at this simple case. How do you solve if absolute value of x equal to absolute value of y? Write it down on the side. Well, when you want to solve this, then you say what? Either x equals to y or They are opposite, right? Because when you take the absolute value, they all become non-negative. Am I correct? So when you have this kind of equation that both have absolute value, but remember, they have to have very clean absolute value, okay? That means x equal to y or x equal to negative y. Okay, so now you have this problem. What would you do then? Well, then you would say the stuff must be equal or the stuff are opposite. That's what I say. Okay? Either the stuff on the left equal to the stuff on the right, or the stuff on the left is the opposite of the stuff on the right. Then just do it. So that means 2x plus 1 equal to x minus 5, or 2x plus 1 equal to opposite of x minus 5. Right? This is the key part. All the instructors will look for this understanding. If you get this, you get the major points of the problem. The rest is just algebra, simplification. Sorry? No. It's just like this. It's just like this. What do you mean? It means x equal to y or x equal to opposite of y. You don't say x change or not. You are saying that you ask yourself, what is x? Oh, x could be y. Or x could be opposite of y. You don't want to memorize that. Do I put a negative sign? No, that's not your true understanding. Your understanding should be, what is x? X could be the same as y, or x could be the opposite of y. This is the right way of thinking, right? Okay. Sorry? Minus what?
Minus 6 and the other one x.
It's like this. Yes. So you try to solve it. The rest is easy, right? The hard part is, how do you understand it? Do you understand it now? Okay, so x equal to negative 6 or x equal to 4 over 3. Okay, there are just 2 points on the number line, and that's it. So far, so good? All right. For the above C, you want to try? You want me to try? Okay, let's try. Is everybody ready for the part C?
Yes.
Okay, let's go. For part C, what should we do? Can I have 7 minus 3? No, right? We have to take away 7 first. Am I correct? So after you take the 7, you have negative 3 times absolute value of 2x plus 1 equals to what? 6. Is that okay? Does it make sense? Okay. And now this is negative 3 times that. So you divide both sides by negative 3. Now you tell me, what do you get? You get absolute value of 2x plus 1 equals to 6 divided by negative 3 is what? Negative 2. And you say, awesome. Hey, absolute value equals to negative value. Is that possible?
No.
Impossible. Okay? And you thank me. You don't need to do any work, right? Because it's impossible. So what do you answer? No solution. Why it is impossible? Because absolute value always greater than or equal to 0. So it's impossible. Because absolute value is non-negative. Okay? All right. Let's go to the next. So the set notation is either this, or you can write in this symbol. Okay? All right. Now, number 5. This is quadratic equation. I think you can do it when you go home. Let's do number 6. You have A, B, or C? 5C? Okay, 5C. Thank you. Awesome. Awesome. I need your input. What did you do? Can you tell me what is your answer? Share with me. Somebody say 0. Okay. Somebody say 0. Any other people say any other things? No. How did you find that? Thank you. Somebody say that. Oh, what did you say? Divide what? Divide both sides by 2y. He kept saying divide, divide, divide. It's awesome. When you divide, you have to make sure you have to divide by non-zero number. Am I correct? When you say divide, you divide both sides by a number. That number has to be not 0 because you cannot divide by 0, right? And he wants to divide by 2y. And I reject it. Because what? Because you don't know what is y. Okay? All right, so it's good. What is your name? Say that again. Jamie. Divide both sides by 2y. Okay, so he has 2y over 2y equals to 16y over 2y. Okay? He wants to write again, and I hold his hand and say, no way, you cannot go. No, no. Why? You may not continue. Why? Why? You must guarantee 2y is not 0 before you continue. But can you guarantee that? No.
Can we divide by 2?
Okay? You cannot guarantee that. You cannot guarantee that. So, okay? So don't go that way. However, he has a wonderful thought. Okay? He sees something, so instead of doing that, it's very interesting. When you do dividing, you are doing the right strategy, but you have to be careful. You have to divide by non-zero numbers. So Jamie, give you another chance. What do you want to do? Wonderful. Subtract what? Subtract both sides. Everything has to be for both sides. Subtract both sides by 2y. Okay? Well, for subtraction, there's no any restriction, so you have 2y subtract 2y equals to 16y subtract 2y. You can do subtraction anytime you want, right? So you get 0 equals to 14y. Now, 14 times y equals to 0. Now it's very clear. You divide both sides by 14. Can I divide both sides by 14? Because 14 is not 0. Right? Because 14 is not 0. So it is allowed. I can divide both sides, but by non-zero number, right? So Jamie, you can continue. So what is the next? So you get what? Y equals to 0. So your answer is just 0. Thank you, Jamie, for asking this question. This is a very good question. Okay? All right. Let's continue. You have A, B, or C for part number 6. Which one you want? A or B or C?
A.
You want to do A? Now let's do A then. Now, this is very important to know that you are dealing with the equation or you're dealing with the expressions. I always ask you this question for a very important reason. Anybody can tell me why I kept asking you, is this equation or expression? Because if it's an equation, I can have two properties to work, which are addition property for equality. The other one is multiplication property of equality. You can multiply both sides or divide both sides by something, by the same expression, right? Or you can add or subtract the same expression on both sides. But if this is not an equation, and it is just an expression, then you cannot do that, right? you can only rewrite. When you rewrite, you can only multiply by 1, or you can only add by 0. So you are not changing the expression. Does it make sense? Okay, but now you are lucky, you have equation, right? So you have both sides. You can do the same action on both sides. You have denominators. So if I want to solve this equation, I can multiply both sides by LCD. Okay? And I'm allowed to do that. So what is LCD? X times x minus 1. So I'm multiplying both sides by LCD. Okay? That means I multiply every term by LCD. So x times x minus 1 times x plus 3 over x minus 1 plus x times x minus 1 times x plus 5 over x equals x times x minus 1 times 3x plus 1 over x minus 1. Okay? Make sure that you're treating all those as factors. You can put parentheses to remind you, okay? So now x1 and x1, they are common factors. You can divide out. X divide out with x. x1 divide out with x1. So what do I have? X times x plus 3 plus x minus 1 times x plus 5 equals x times 3x plus 1. Does it make sense? Mm-hmm. Okay? Okay, when you multiply LCD on both sides, it's only for equations, okay? If it's expression, you have to keep denominator. Okay? All right, now, we get rid of the denominator by multiplying both sides by the LCD. What's next? You just what? Distribute it, combine like terms, and solve, right? Let's distribute. What do you get? X squared plus 3x. And then? Plus x squared. And then? Plus 4x. Thank you. And then? Minus 5. Great job. Equals what? 3x squared plus what? 1x. It's x, right? Okay, now let's combine the like terms. How about x squared? So let's move. Okay, you want to combine this first. Okay, 2x squared and then what? Plus 7x minus 5, right? Equal to 3x squared plus x. Okay. Now what? Next. Okay, subtract 2x squared. So you have x squared here. Subtract 6x minus, subtract 7x. So you have negative 6x here. And then add 5. Is that right?
Yeah.
That is correct. How did you factor, Jamie? X minus 1, x minus 5 equals 0. So what do you get? X equal to 1 or x equals to 5. I want to give you a warning. I saw some of you not writing equal to 0. You have to, okay? You must. This is an equation. Don't miss that, okay? When you subtract off everything, you still have 0, right? So there are two sides. Okay, now, am I done? No. Can I say bye? No. I miss you. You have to check, right? Okay, you have to check. Natalie, how do you check it? Okay, tell me, how did you plug that back? No, I don't want to. I'm lazy. I'm not going to do that kind of hard job. I want to do some easy job. I want to check something first. The domain. What is the domain? 0. 0. No. What is the domain? Domains are all the real numbers except 0 or 1. Because 0 cannot be your domain. That makes the denominator 0. 1 cannot be your domain, right? Yes. Okay, so very quickly, Natalie, you can say, well, when I get x equal to 1, you cross it and say, sorry, this is not in my domain. Because it makes the denominator 0. Am I correct? Okay, now next, you try to check whether it makes the equation true. Does it make sense? And I will have all of you check it when you go home, because we don't have time. Okay? But mental math. You can still do some Okay, do mental math. Okay. What is 5? 5 plus 3 is what? 8. 8 divided by 2. 8 divided by 4 is what? 2. Okay, 2. Remember, 2. 5 plus 5 is what? 10. 10 divided by 5 is what? 2. Okay, 2 plus 2 is what? 4. Okay. All right, 3 times 5, 15 plus 1, what? 16. 16 divided by 4 is what? 4. Is 4 equal to 4? Yes. Okay. Oh! So what is the answer? So this is the answer. You're writing solution set. Okay, I like all of you, okay? Make sure you finish this whole packet. Can I make this request? So tomorrow, you must turn this in completely, okay? All right. Today, I want to give some of you some extra points if you're coming on time. I know some of you not. You're not. You're not. And there's one person not. You sign it up. It's the owner system. You're not. But come on time tomorrow. You will get it, okay? I love today's class. Thank you.